All right, good morning everybody, and welcome to our Wakanda webinar series. Today's webinar is an introduction to data modeling. My name is Michel Guerin, and I'll be the host for today's webinar. So on the agenda today, we'll start with a quick introduction, no more than 5 minutes. Then we'll go over some of the Wakanda features, just to make sure that everybody is in sync about Wakanda. And we'll have a nice 40 minutes introduction to data modeling. We will then wrap up the session with some pointers to additional references. And finally, we'll close with about 10 minutes Q&A, question and answer session. Just note that to enter your questions, you'll have to type them in the chat window. That's the same as the one you see in the picture here, and that is provided by WebEx. Feel free to add your comments and your questions during the presentation. However, we will answer them at the end of the session. All right, quickly, the highlights. What is Wakanda? That's for, in case some of you, got into the webinar and by accident. So Wakanda is actually a complete solution for web and mobile applications. It is the first integrated solution. It includes what you see is what you get GUI builder. It also has, and what's going to be relevant today, model-driven architecture. It includes a NoSQL object database, and of course, it's a whole JavaScript stack that supports, fully HTML5 and the CSS3. Our speaker today is Dave Terry from PDM, which is Pacific Data Management. Actually, today it will be Pacific Data Modeling. Dave is project manager at PDM. He has over 30 years experience in development, mainly developing database applications. So without further ado, let me introduce you to our speaker of the day, Dave Terry. Hi, Dave.
Hello.
Are you ready?
I'm ready.
To talk to us about data modeling?
Sure, no problem.
Go for it.
Okay, so first off, let me, how do I get control of this thing? Here, there we go. Thank you. Okay, so let me share my screen. I don't have the share my screen button anywhere.
Hey, Dave.
Yeah?
Quick start tab on the left, and then share my desktop.
Okay, thank you. There you go. Okay. Okay, so first off, Wakanda is a development and deployment system for web-based, data-driven applications. I make that distinction because it is particularly good at handling data and delivering it to the web. At the heart of a Wakanda application is what's called the data model. And as that name would suggest, it is the definition of all the data classes and all the attributes and all the information that is going to be stored for your application, to make up your application. So yes, it is that, but it's also more than that. It's meant to be where all your business rules, all your business logic, everything is stored in one logical place and interacts. With a data model, you can govern access to data classes and attributes using scope, which controls what pieces make it to the browser. You can use events on entities for initialization, for loading, for validating, for saving. You can define data class methods, which are, in essence, your stored procedures, and you can define those at the entity, collection, or data class level. And you can even use inherited data classes, so you have a degree of hierarchy to the data in your model. You can use restricting queries, which control access to entities based on any conditions you want to set. All of that makes up a Wakanda data model. In fact, there's quite a bit more. I'm just trying to keep it short. So the main thing I'm going to show you today is going to be the 4 basic kinds of attributes, not every single last piece, because I just don't have the time. But I'm going to show you a little bit about data modeling and the 4 basic kinds of attributes that you can have in your data classes and how they work. Now, the way I'm going to do that is I've created a data model already for this webinar, and you can see it here. It's got 4 data classes in it. And what I'm going to do is I'm going to create this from scratch in a brand new project. But every single time that I want to demonstrate something, I'm going to switch back to this because I've already imported some data into it so I could show you exactly how things work. But before we go any further, let me just go through this model real quickly. What is this model? It's not that complex, really. This is meant to be a model that would work for a school. You've got students, teachers, the courses that the students take and the teachers teach, and in essence, a joining data class called attendee. For each attendee, it points to a student, took a particular course, and its real information that it stores is the grade point that you received. 3 for a B, A for an A, 4 for an A, and so on. So attendee is a mini data class to the student and to the course, and the course is a mini data class to the teacher. Okay, just so you get an idea of what the relationships are between these data classes. So let's start. I'm going to create a brand new project. I'm going to leave it blank, and I'm just going to call this demo. Now, for each project, you get a new data model. And if I say I want to open that model, it's initially blank. Wakanda tries to help you by saying, well, you're going to need at least 1 data class. And the first thing you want to do when you're defining new data classes is come up with a very good name for each class and for its plural. So, for instance, in this case, I'm going to call this student. It's way over here on the right. And it's going to give me the suggestion that the collection name, when you have more than 1 of these, it's called the student collection. I don't like that. I like calling it just flat out students. Now, what I do is I create several data classes in a row. I'm going to go, I want attendee. Oops, let's just put an S on the end. Another one, call this course. And one more, call it teacher. Now, here are my 4 data classes. Notice how I just created them first. I think that's better to do to try to put down all of the data classes that you're positive you're going to need, the obvious ones, generate them all. You notice also that the first thing Wakanda did for me was it created a key for every one of these. Now, Wakanda automatically generates a key of type long integer, and that is a sequential number. It's automatically incremented for you and taken care of, and that's good enough for me. But if you felt like you needed a different kind of key, you feel free to change it at this point. If you wanted to make it a UUID, or if you wanted to change the type to a string or whatever, you could do that here. Okay, so that's the first thing you want to do. The second thing you want to do is you want to add your storage attributes. Now, what a storage attribute is just exactly what it sounds like. It's basically a field. It's a place where information is truly going to be stored in the data store and retrievable and editable and so on. So I'm going to create a few of those real quickly here. We're going to call it first and last. I'm going to make them strings. Over here under attendee, I've got my grade point. which is a number. Under the course, I might have, say, a name for the course, say a semester, and a year. I can make that a number if I want. Teacher, we'll give it also first name and last name. It's not that hard to create storage attributes, and what you're doing is you're defining all these things are going to be stored in the data store from here on. So let's see what a storage attribute behaves like. I'm going to switch back to this model, and I'm going to open up a piece of JavaScript code. This is going to run against the completed model with the data in it. Now, where we are right now is we're in a piece of JavaScript code being shown in Wakanda Studio, and when I execute this code, it's going to run against Wakanda's server, and whatever item is in the very last line of this code, whatever object's there, this Studio is going to give you a visual representation of what that is. So for instance, this up here is the syntax for finding an individual entity out of the student data class. And I'm looking for somebody named Fred, whose last name starts with V-E-N, and I'm putting it into X. And then down here, I'm going to show you what's in X. So if I run this, you get a Wakanda Studio's representation of a single entity. If this had been a query, then I would have got a representation of an entity collection, so a bunch of them. But let me give you an example of what you would normally do with a storage attribute. So this guy's last name is Vinieri. I'm going to get rid of the Y. It's pretty obvious. If I save this, and then let's say I look it up again, just to be sure we're looking at fresh from the data store. Okay, so now it's a query, so this is a collection of one. You can see that his name has been changed to Fred Vinieri. So now, if I want to, obviously you also use storage attributes for querying. So let's get rid of this. And storage attributes can be indexed in a variety of ways so that they're nice and fast for whenever you want to do lookups. So here's what a collection looks like when you find a bunch, at least in the Studio. Now, one more thing you can do is even on a collection, you can use attributes. So for instance, in this case, I'm using the last name attribute on a collection of students, putting it back into X, and then I'm going to display what it shows you. So, and what it is if you can use attributes on collections, storage attributes on collections, and it will give you an array. And there's a variety of different tools for you to do those kinds of things. So let's go back to the model and talk about the next type of attribute. The next kind is called calculated attributes. A typical one would be something like this. Full name. You know how you always design your database and you put in first name and last name, and then you always needed the full name because you use it over and over again. So this way it lets you institutionalize that and capture all the behavior in one attribute. So full name is not going to be a storage attribute. I'm going to go over here, I'm going to say, I'm going to turn it into some JavaScript. And when you have a calculated attribute, first off, it shows these little blue lines here. And the main thing you have to define is the onGet. That is, when this attribute is accessed, how do I determine this value? So I'm going to go ahead and add that code. And it's just going to be very simple. Return this dot first plus space plus this dot last. When you're working inside of a calculated attribute, the keyword this refers to the entity in which it's being called. So this is something that we've done a lot in the documentation because it makes sense. It's really easy to understand. Well, every time I now want to see a person's full name, I just use this attribute instead of the individual first names and last names. a more interesting example I'm going to show you. Let's say I wanted to turn my grade point into an alphabetic grade. So instead of 3.33, I want to show B+. You would do that also with a calculated attribute. You'd give it grade, and it's going to be of type string. And then you would go ahead and say it's going to be a script and start filling it out. I've already done that, so you don't have to watch me type. I'm going to show you this completed in the model that I already did. So here you go. Here's grade point, and here's grade. And I have filled out all 4 of the different events that are associated with a calculated attribute. So let's go through these events real quick. We've got onGet. Now what onGet does is it defines an object that has as its properties 0, 1, 1.33, 1.67, and so on, all the way down. And then as its values for those properties, D, F, D plus, E, whatever. So turning it into a grade, an alphabetic grade, is just a matter of getting the grade point, using it as a property on GP, and then returning it. Now, I could have defined this object somewhere else so that I don't have to keep recreating it, but I just wanted to make it easy for everybody to see and understand. So that's onGet. Your purpose there is to take the current entity and return a value out of this attribute. And I'm going to demonstrate that in a second. Let me show you the rest of these events, though. Okay, so there's onSet. You're not limited to only getting a value out of a calculated attribute. It is completely legal for you to define what to do with a value that's assigned to a calculated attribute. And that's what the onSet's for. The onSet is, in my case, it's just the reverse. You're passed a value. You have to determine what you're going to do with that. And my goal at this point is to update the grade point. And I'm doing it basically creating an object that's the reverse of this one and then just putting the grade point back into grade point. Now there's 2 more events on a calculated attribute, and they're quite different from the onGet and the onSet. And these are called onQuery and onSort. And here's what they do. You don't need them. If you don't put them on the calculated attribute, then when this calculated attribute is queried, it will just calculate the onGet for each entity it's trying to examine. But you are provided an opportunity to make that a lot faster. And what this does is the onQuery's task is to turn the query that is being done on this attribute into a query on, say, another attribute. So for instance, let me show you the code for that. So when you get an onQuery, you get 2 things. You get the operator and the value. And what's going to happen is you're going to produce a string and return it, and that string is going to get substituted into the query right where this calculated attribute was used. So for instance, in this case, I'm doing a very similar thing that I did before, but fundamentally what I'm doing is I'm turning it into a query on grade point, where I'm saying grade point is greater than, less than, equal to, whatever, that value, which is the numeric value. And the result is that instead of querying the calculated attribute, I'm always really querying the grade point attribute. Okay, and then the last script is onSort, and that's not really complex at all. Fundamentally, you're told whether you're ascending or descending, and then I just substitute grade point for it. It's very easy. Now let's see some of that stuff work. Okay, so here's some code. If I run this real quickly, you'll see I've got a single attendee in X. This syntax up here is how you find an entity by key. So here I've got stuff down here, and you can see that the grade point is 2.33 and the grade is C+. If I change this, it's already that. Hold on. Let's do this. And I save it, then you'll see that the grade changes. The grade point was assigned, but the grade also changed to B- because it's a calculated attribute. If I want to, I can put it back to what it was. And it goes back. Now, that's good, but you can also, since we implemented the onset, assign a letter grade. Oh, let's give this person an A. You can also assign directly to the calculated attribute. And notice how it also updates the grade point. Now, you're not limited to just assigning and getting a value. It also works out of a query. So, for instance, I'm going to give you a query here. Here is a query using grade point. So I'm saying find all the attendees where the grade point's greater than 2.33 and less than 3. So I guess this is only B minus people, I guess, is what this is going to give me. And I'm going to show the grade point down here. And here it is, yeah, all those. There's thousands of them. But that is just as fast. I mean, this is just as fast as that. Whoops, sorry about that. This is doing the same query, but on grade, which is calculated. And I'm going to take this down here, and I'm going to show you the grade. Same speed, because it's been redirected to the grade point. And sorting works the same way, and so on. So the nice thing about them is you can use these to fill out your data class exactly as you would want it to behave, and then you can use those calculated attributes wherever you want to, and you can give them as much capability as you want. So let's go to the next thing. After calculated attributes, you typically would begin linking your different data classes together. So for instance, an attendee is a student taking a course. So I'm going to show you how you would create what are called relation attributes that relate different data classes. First, I'm going to say this is going to be called the student. The student in this attendee record is of type student, and that's it. You can see that it added a new attribute. It's of type student. It related it to students, and it even added the reciprocal, the reverse, on the other table. So these are, I'm going to rename this. I'd like to call it something a little bit different. Naming things are actually one of the biggest challenges here. Attendance. So a student's attendance are these, and an attendee has a student. Well, of course, it also needs a course. So we'll say the course, and that's of type course. And now we have in courses the people that attended the course. Of course, the course needs somebody to teach the course, so we're going to say, I don't know, the teacher is of type teacher. And now over in teacher, we've got the reciprocal, and those are the courses that this teacher taught. Everybody got this? It's not that hard. For each teacher, there's multiple courses. For each course, there's multiple attendees. For each attendee, there's a single student and a single course. Now, let's see that actually work. Okay, so now back over in the model that has all the data in it, and I'm just going to look up some courses using the year. So there's a whole bunch of them. And if I want to get a single one out of there, this is the syntax for finding a particular entity in a collection, and then I'm assigning it back to the same variable X. So now here's a single course. And you can see that course teacher is defined, and it's picking the course teacher that goes with this given course. So, for instance, if I want, I can say, put back into X the course teacher. There's the teacher. Or, now that's an N-to-1, so I get a single entity. Or I can say, find all the attendees and all the students So these are, actually, let's do this so I don't confuse you. Your first attendees, and then I can string together the student, which is the other relation attribute, and I can go all the way to students. So what it does is relation attributes not only work on individual entities, they work on collections of entities also, and they let you traverse the relational hierarchy, if you will, and information throughout your data model very, very easily. And it makes it very clear where you're getting your information when you're using it this way. So let's do a little bit different thing here. So I'm going to get a bunch of teachers. Okay, here we go. I'm going to pick one of them. Just grab the first one. Here's a teacher. Now, I want to show all the courses that they taught, that this one teacher taught. So X is, at this point, a teacher. It's got a list of courses taught, and then I'm just going to grab the name out of there. So here's the name of all of them. Okay? Actually, let's get rid of this. I'm going to do this for all the teachers, all 20 of the ones that were found. There they are. Now, you notice in here, there's duplicates. Case conference ones, there's duplicates in here. The reason is because I used the same course name for multiple courses, and that makes sense, right? Because sometimes it was taught in 1999, sometimes in 2001, and so on. But let's say we wanted to get that uniquely. You would be able to do that pretty easy using a collection method called distinct values. And now they're only in here distinctly. Now, let's go for a little bit step further. Now, you're not just limited to using relation attributes on collections and on entities. They're also queryable. So, for instance, I want to find all the courses where there's the course teacher has a last name that starts with ZA. And there they are. Or I want to find all the attendees where the student's first name starts with Fred. Nice, easy, quick, very easy. And that way you don't even have to try to think about how many joins you would be doing throughout what all I'm doing here if we were in SQL. It makes it very fluid to go from data class to data class, from logical information to another set of logical information. Here's another one. This one's a little different if you think about it, right? This one is, I want to find all the teachers that taught at least one course that started with PSI in the name. And there they are. So it's very, very fluid how you can use relation attributes to go up and down the relational hierarchy, to use them for queries. You can use them for sorting. You can use them for a variety of different things. Let's go a little further now. Let's go back to our model. Oops, that's the code. Go back to our model. Once you have relation attributes, you can create what are called alias attributes. And an alias attribute is a way of pulling data from a parent data class into a child data class. For instance, let's talk about attendee. If you were ever looking at an attendee entity, you would sure have a relationship to the student. You could figure out the student. But let's say you normally need to look at the student's name while you're dealing with an attendee. So what I want to do is I want to create what's called an alias attribute. And here we go. This is going to be called student name. And the way you create these is you use a path instead of a type. So the path always starts with a relation attribute that's already in this data class. So for instance, the student. Okay. And then use dot notation to say what attribute out of that class you want. That's it. If we wanted to look up the teacher, let's say we need teacher name and course. So a typical way to do this would be oh, I don't know, we'd say teacher name, and it would be the teacher dot, I didn't put full name over there, so I'll just use last. Okay, that's it. And then from then on, whenever you get a hold of an attendee entity or a course entity, you can easily find parent information. And it doesn't have to be just one level away. It can go as far up the relational hierarchy as you want. And it will pull the information in, and you can deal with it. Now, a couple of points. An alias attribute isn't actually calculated unless you need it. So it doesn't cost you anything to put it there. The other thing is that you can have a different set of properties and criteria and permissions levels and scope and all that for the alias attribute that is different from the attribute that it's actually referencing. So it lets you separate information. You could even make it so that, let's say I can't even get to students, but I can still see the student name when I deal with an attendee. So let me show you those. Alias. It's pretty simple. Here's a query of attendees, right? You can see it calculated for every one of those, the student name and the course name, all the way down the list. So if I want to pull out just one of those so I can see it clearly, here's the course name or the teacher name. And of course, you can query on alias attributes, so you can find things based on related data very easily. Let's do, this is not an example of querying on it. I'm just showing you one more thing. So here's all the courses in the year 1999, and then for all those courses, give me their teachers' names. Very convenient. Very fluid when you want to deal with different types of data. Now, the last thing I want to show you is, in essence, a different kind of relation attribute. The first ones I showed you, we call primary relation attributes. Those are the direct relationships between the different data classes. But there is a type of relation attribute that is you define very much like an alias attribute. So for instance, let me give you an example. Let's say for a student, we wanted to know all the courses they've ever attended. What we could do is this, is say, courses, actually, let's just call it my courses. Now, you start again with a relation attribute in the same data class, so that's going to be, for me, attendance, dot the course. So now, whenever I use this attribute, I'm going to get all of the courses that this student has ever attended. And I don't have to figure out where it came from or how I got it. Let's use something even harder. Down here at teachers, I'm going to put in an attribute called students taught. This is going to be all the students I've ever taught. And that would be something like, courses taught dot attendees dot the student. Now think about that. This attribute, when you get a hold of a teacher, will present to you all of the students that were attending any course that this teacher has taught. And what that's showing you is that you can go up and down the relational hierarchy, and the result will be that you get a singular list of students. Students aren't repeated in this list. And it's usually what you want when you're dealing with relational information. So let me give you an example of this. So I'm going to say, find me all the teachers where the course, I've taught a course that has a name that starts with PSI. Okay, there they are. If I pull one of these out of here, you'll see that it's already calculated that there are 131 students that I've taught. And if I want, I can get those students And then I can turn that into a list of just full names for the sake of argument here so you can see them. Everybody I taught. Okay. Now down here, we're going to do one more thing. You can query these also. So this is find me all the students, in this model I called it courses attended, so that have a course that they attended, at least one, named forensic. Okay, so if I do this, here are all the students, and if I pick one of these, that's going to give me a specific student. I'm going to grab that particular student's courses attended, and then I want a list of those names. And somewhere in here should be forensic. Oh, here it is down here. So that is what we call dependent relation attributes. And the reason we refer to them as that is because they're dependent upon some other relation attribute to even exist. And they don't cost you anything until you use them. So feel free to add them to your models and explore all the different capabilities you can have doing that. Now, the last thing I want to say is I've got the same slideshow from Michelle, but I just wanted to make some points here. Okay, so when you're designing your model, try to put as much of your business logic and rules into your model. If you get it into the model and design it correctly, it will save you a lot of time downstream. Before you begin, try to be aware of all your options, including all these different kinds of attributes, but also, you know, scope, restricting queries, inheritance, events, class methods. There's tons of different things that make up a Wakanda data model, and if you can really understand those, it will clean up all the work you need to do. Try to complete your data classes with all the needed elements that your application is going to want in an entity. You don't have to do everything. Don't just add alias attributes because you can. Add them because they're needed for your application, okay? You'll eventually learn about inherited data classes. You're going to want to use those to create situation-specific versions of your data. And maybe in a future webinar, I'll go through that. You want to build your security directly into your data model. That's the best way to ensure that nobody can spoof information in your application. One of the most powerful things you can do is use scope. Scope lets you govern what items, what data classes, and what attributes are even available to the browser. And you want to use restricting queries to control which entities are available under what conditions. And last piece of advice I can give you is look at as many different data models as you can find to get ideas of how you might structure your data. Okay? Now, there is a certain order to the creation of a data model, and I've pretty much just done it here. So, but let me make sure I make these points, okay? Generally, I create all the data classes that you're absolutely confident you need. Don't just create extras, but create the ones you're absolutely sure you have, and give them a well-named singular and plural name, whatever your convention is. At that point, change the key type if you're going to change the key type. It's better to do it at the beginning than to do it later on. Pick one of the main data classes and fill out all the obvious storage attributes. Don't worry about the order of things. You can reorder all the attributes later on, but fill it all out. And even you can do the calculated attributes at that point, those that are based on the storage attributes you just generated. Then do the same for all your data classes. Fill out all their storage attributes. And then start adding a primary into one. I always do it from the into the one relation attribute on the data classes that are at the bottom of the information hierarchy. For instance, in my example, that would have been the attendee data class because it's going to need references to student and to course. So you add your primary into ones, make sure you name them correctly, change their names. If you leave them at the default names, it may get confusing later on. So it's best to name them from the point of view of the entity that you're creating, the data class you're creating. And then you do that for all your data classes. Then, after you've done all that, add your dependent relation attributes and your alias attributes. And after all that, then you start adding events and methods, okay? That's when you start actually coding things, basically. Now, we've seen a lot, but we haven't seen everything. What we haven't seen anything about data class events and methods. We definitely have not explored restricting queries, which are very, very useful. We haven't even talked about inheritance or scope or anything to do with permissions, users, or groups. And hopefully we'll be doing that in a future webinar. That's all I got for today. Thank you very much.
All right, thank you, Dave, for that great and nice introduction to data modeling. I'd like to tell everybody here that actually this is the first of a series of 3, right, that we are planning to do. So that one was an introduction to data modeling. The next one will be for intermediate users, right? And the third webinar would be for more advanced users, right? So everybody stay tuned to make sure that you're aware when we're planning to do those. All right, in the meantime, I'm trying to share my application here. So let's go about a few references before we move on to Q&A. Make sure, of course, that you check the wakanda.org website. This is where, when we have anything new, we put it out there. Check the forum, and I would invite everybody to actually subscribe to the forum so that you can ask questions there too. Of course, check the documentation. Check us on Twitter and Facebook. The one thing I need to tell everybody also that we have still a call for papers or the JavaScript everywhere in our Wakanda. This event that will happen October 26 and 27 here in lovely San Jose, California. So we'd love to see you come and do a presentation on what you're doing either with Wakanda or with JavaScript. That's it for me here. Thank you for coming, and if you have questions, make sure that you type those questions in, and we'll start answering them in about 1 minute. All right, so we're actually ready to go much faster. So let me introduce you to who's with us here to answer your questions. Of course, we have Dave Terry. We have Jürgen Fesselmeyer. Jürgen is a product manager for Wakanda. We have Bill McKay, who's helping us here, will be reading the questions for us. And there's, of course, Michelle Gehring here. I'll try to answer questions also marketing related or business related.
All right.
Okay, Bill, shoot.
First question. How can I place Wakanda server in the cloud, like on Zoho, Amazon, or Cloudant?
All right. Well, why don't I take that one on? The marketing guy, right? That's actually a good question. You can totally put it in the cloud. We've done that, especially with Amazon EC2. So Wakanda is there. We also work, I don't know how much I can say, but we also work with making sure that it works on other cloud platforms out there like Microsoft Azure and those like that. What we're working on now is providing you the steps to do that, so that some kind of documentation or creating a screencast. And I think Jürgen, you're going to work on that, right? So yeah, so make sure that again join the forum so that as soon as we have that screencast available, all the steps documented, you have access to it. We'll also subscribe to the newsletter. We'll put it in the newsletter too.
Okay, second question. Is there a free sandbox public server where I can use Wakanda for testing?
Sure, I can take that. Today there isn't, but we can. We're working on creating some EC2 instances to host, solutions. What Michelle mentioned before. So we are we're looking into that, and so you will hear more on that if you join the forum, or if you go on the forum. We'll post more material on how to do that, how to create your own, how to push your sources and solutions to your own VPS or servers, or if we're going to provide a sort of a free sandbox in the future.
Yeah, I think the idea actually of having our own live version that people can try and evaluate that there is actually a very good idea. So yeah, this is something we're really going to look into and work on.
All right. The next question is to me. Yes, there will be a recording of this webinar, and I will be sending that out in the next day or two, so be expecting that. Similar question is, will the demo code be available?
Yeah, the demo code that Dave showed today will be available on our GitHub account. That's GitHub/Wakanda, and under the webinar, Wakanda webinars repository.
So we'll put all that information actually in a follow-up email where we'll tell you where to find the recorded version and maybe also where to retrieve the code.
Okay. How can we develop 4 people at the same time?
I can take that question also. So I'm assuming that you are doing that in a team environment using like Git. You can use Git today, and you would just, as with any other development solution, commit your sources into your repository and push them if you need to a Git remote. So that would be the same development process.
Okay. What is the recommended workflow for designing web pages and developing in Wakanda, since the studio is not a replacement for design software?
I can take that also. That's true. It's not a replacement for design software, but our widgets and our WYSIWYG editor are pretty good getting a head start on your website, and it's not hiding anything from the developer. So at any given point, you can go into the HTML source code, edit the sources yourself, and continue the application that way, or go back into the WYSIWYG editor and add elements to your web page. Okay, this question's a pretty big one. Here we go. Calculated attributes seem to be similar to using 4D trigger. OnGet seems to be equivalent to onloading record event that was taken out of performance for performance reasons. Is performance a concern with Wakanda?
Dave, can you take that one on?
Well, performance is a concern with every data product in the world, so I don't think currently that there's any particular concern with the onGet. You got to remember one difference is the onGet only fires when you access that attribute. So if you're not going to be accessing it, then it won't cost you anything. If it's small and discrete, it's not going to be a problem at all. If it's really complex, let's say you have a calculated attribute, looks up other entities and does some math, yeah, I mean, at some point maybe you would want to change how you behave and make it turn it into a method so that it doesn't just run when you deal with the entities, all the entities attributes. But no, I haven't noticed any problem yet.
Hey, there's another question. I think it's for you also, Dave. People are asking, how different is Wakanda from 4D? What is 4D, and is it better, since you're the one who has experience with both products?
Depends on what you're doing. If you're trying to design a desktop application, use 4D. If you're trying to design a web-based application, use Wakanda. It's that simple. I personally, and I did a keynote on this a while back, I don't really like web design, personally. I found it really hard to do until I started dealing with Wakanda. Now I love it. So if I'm going to be designing a web-based application right now, I think it's the best tool.
All right, next question. Can you apply CSS within the studio, or do you have to place the tags on the HTML and CSS files outside of Wakanda?
The studio also writes CSS for you.
All right. That's it for questions, actually.
Yeah.
That's all the questions we have.
Oh, another one.
So, okay. Yeah, no?
Oh.
So if anyone has any final questions, this is the time to submit.
There's one here. If 4D is for desktop, then how will Wakanda differ from 4D after WebSockets are implemented in Wakanda? Anybody wants to address that?
I
didn't understand the question.
If 4D is for desktop, then how will Wakanda differ from 4D after WebSockets are implemented in Wakanda?
Wow. I mean, if you're familiar with 4D, it's not, there's almost no, I mean, there's a data engine in both, there's a language in both, but the language is completely different. It's not JavaScript. 4D applications are precompiled. Boy, there's so many differences. I could have to do like an 8-hour seminar on just the differences. So right now, they're not really. Wakanda is designed specifically for web-based applications, and 4D, although it does have it is also a web server, its forte is desktop applications. So that's how I see it. I'm not a 4D employee, just so you know, so it's my opinion.
Hey, thanks for sharing it, Dave. Last question that we see, is there a full feature sample application plan? So the answer is yes. We actually, there's some attempts already to provide some applications. So you go to GitHub and there's a sample apps, right? If you go to Wakanda GitHub, you'll find a folder there for sample apps. So in there we have one from Dave Robbins already, which is a PTO application. It's not full featured yet because he's still working on it, but it's really a nice example for you to kickstart your development and to look at how you create a web application. And we are working on some other ones, so yes, the answer is yes, yes, yes on that. That's it for what I see. If there's other questions, we'll follow up in an email and answer those. So yeah, that's it for me. So thanks a lot for everybody for joining this webinar. Again, as I expected another one, the number 2 on data modeling coming soon. And see you soon on our webinar series. Thanks again. Bye-bye.
Thanks.